Yep,
There we go.
recording in progress.
All right. And wait, there we go. Everyone can see the slides all right?
Yep, can see it.
Yeah.
All right. Well, good evening. Tonight we'll be talking about how to do replication in SQL. The genesis of this talk was the last month's talk. Last month, I discussed how to connect multiple databases in a Ruby on Rails app. And part of that discussion was setting a database as replica. And um, basically in the Ruby on Rails ecosystem, if you tag a database as replica, it treats it as a read-only database. It's just telling the application, we only want to read data from here. We don't want to write data from here because data is probably getting copied. So in this talk, we're going to be talking about what's happening behind the scenes in SQL and how to set up different replication strategies. So small agenda here. I'm going to quickly go over some use cases I found for replicas. Probably not an exhaustive list, but just some usages I found for setting this up. And then we're going to cover MySQL, two rather similar physical replication strategies, and then go do a quick demo with a Docker environment on that. And then we'll cover Postgres, which has a physical replication and a logical replication strategy. So we'll discuss those and similarly go into some Docker containers and configure those up. So when to use replica databases. Common use case I see is you have either people accessing your app that are performing heavy queries or secondary services such as like BI tools or other reporting tools that are directly connecting to your database, constructing complex queries and running them very frequently. If there's heavy enough read load, we don't want that load impacting the efficiency of our writes. So we'll often set up a replica, that will take data from the main database, and all of our reads can happen there without impacting the performance of the main database. Another, I mean, I guess a similar case, I think I haven't encountered this personally, but if you have applications that are have very heavy read things, so if you have a lot of users maybe getting like news status or various aggregate statuses, they're constantly hitting your application. Maybe you want those to occur on a separate database while your write activity is happening elsewhere. Another case I've personally seen, although I'm sure it's not too common, is you'll have a customer that actually wants database credential access, which is a little bit scary, but I've seen that happen. Obviously, you don't want them performing writes to your data. So a couple options are A, set up a replica that's a read-only, or B, you can also create a read-only user that they can connect to. The other usages are related to backups. So if you have a replica that is up to date, then if your main database goes down, you can either use that as the new primary, or you can just take regular snapshots of your backups via replicas. Yeah, I'm sure it's not an exhaustive list, but I do see a lot of like performance related reasons and backup related reasons. So let's talk about MySQL. So I believe this is categorized as physical replication, but we have something called a binary log, which is a log of all activity. So anytime you create a database, create a table, insert data, that gets put into this binary log, which can then be uh, used in other databases, other MySQL databases to replay that activity. So if you uh, configure replication on the secondary replica side, you give it the credentials of the primary database. It will then read the binary log. It'll actually copy it to its own uh, log called a relay log, and then from there it will replay the relay log onto the onto itself. So yeah, all events are picked up here. So this is schema changes, whole database changes. So you create a new database, drop a database, any data transactions will be picked up by this. There's another method though called GTID, or global transaction identifier. And this also uses the binary log, from my understanding, but um, the configuration is slightly different, and it's based on the position of the binary log. So with the previous method, which is older, uh, when configuring this, you have to give it the position you want to start at. And I'm sure this has to do with being able to retroactively replay data. If you're setting up a replica and you wanted to get historical data, maybe you do that. Or if you want to start it from just current, then you can do that as well. But with GTID, I think it tries to figure out uh, roughly where to start from. So you can get it like an auto position, and it'd either be the beginning or later. And I think it from there tries to figure out exactly where in the log to start from. I put here that it's easier to set up than a binary log. Further testing, I'm not sure it's entirely the case. They both have separate configuration options. Uh, Different posts that I've read seem to indicate that uh, this is the more recommended method, but that's what I've found so far. So let's do a little demo. I'm going to start up a Docker container, or Docker Compose. So while that's running, I'm actually going to show this Docker Compose because this has our configuration. And ordinarily, I think these would go in a configuration file, but so I guess higher level, I'm starting two MySQL servers. Oh, I didn't put the right password in. There we go. I have one called primary, one called replica, and they're running on two different ports. And here I'm just setting a bind address, but I'm also setting a server ID. So each server in your network must have a unique identifier for replication to work. Let's see what other notes I have here. I think it's just that, and then creating replication users. Okay. So I'm actually going to start up, one second, my SQL workbench. I got to move this over. So I'm going to connect to that. I'm actually going to connect to both of them. All right. So connected to both the primary and replica, I have two scratch pads that I'm going to load up here. And by the way, we're doing the binary log approach first. Okay, cool. So first thing we're going to need is a user that the replica database will use to connect. So create that, and then we have to give it replication slave permissions. Okay, cool. So that's set up on the primary. On the replica, we have to set up the replication source. So this includes your database credentials like host, port, user password, but it also includes the name of the log file and the position. So this would be like the start position. Now this is like this particular position is going to change. This was the last time that I tested it. So in order to get this data, we have to run show binary log status on the primary. And that's going to give us a little bit of data here. So this is the name of the file, and this is the position. This is the last position. So, and this is probably based off of all write activity. So like we just turn on the database, we created a user, we did flush privileges and all that. So that probably contributes to the latest position. So we're going to, the log file is correct here. I'm going to change the position to 857, and we'll go ahead and my cursor is not, that's odd. You have to use the trackpad. That is strange. Can I do this? Might actually just be my monitor. Let me try something here. Yeah, okay. For me, it's not showing the whole line as highlighted, but it did change the replication source. And it's giving a warning, but it's just complaining about insecure password on the user. So that should be set up. So from here, we should be able to start the replica, and that's connected. Let me just make sure that it's not logging any errors back here. Looks like it's good. So from here, we should have replication all set up. All activity from the primary database should get replayed onto the replica database. So to demonstrate that, I'm going to create, let's see, how do I close this? That's fine. Let's minimize it for a sec. Cool. Let's create a database. Use that database. I'm going to create a users table and then insert a user. So that's all set. We see we have one user on our users table. So now if I go to the replica, I can use this database. That was successful. And then select from that table. And here we see we have the same record. So we are accurately replicating data. So let's have some fun with this. So I'm going to update that record, give it a different email. And then on the replica side, reread our records. And we see that the updates have come through. So there's a couple interesting things here. What we've seen so far is we've created a database, we've created a table, we've inserted data, we've updated data, and all of those events were replayed. But even though this is a replica database, we are allowed to make changes here, but we are allowed to write to this ourselves. So where this could get dangerous is if, let's say, we copy our update command to say, let's do that. and then I select from that table again. See that the email has changed on that user, but the replication is not both ways. So if I select from the primary, the data hasn't changed, but I could still perform activity on the primary, and it'll cross over to the replica. So if I deleted the replica, or if I deleted the record, um, it would delete from here as well. Now, so you have to be careful if you're doing secondary writes to the replica, but there's definitely a use case for it, and that's maybe you want to have some kind of audit history or some other tracking history on the replica. If you have other databases and other tables that don't exist on the primary, then you're most likely okay to write to the replica, but just with the understanding that the primary database does kind of have full access to that. So if you created a database in the replica, and then you created another one with the same name on the primary, and then you go and drop that database, it's gonna drop it from both. So it's just something to keep in mind there. Went over a lot of stuff. Any questions so far?
The the file that's where the binary log is,
Yeah,
I think you showed that. Is that running inside the container, or is that file on your local file system?
that should be in the container. We can look at that.
Okay. Yeah, I think, for demo purposes, it's fine. One thing I ran into when I was using this type of setup was that if the container somehow gets nuked or corrupted, if that file system, or that file is in the container file system, you lose it. Whereas if you have it mapped as a volume from your host computer in, then if that container, for whatever reason barfs, you can still get to your data.
Right. Seem to remember there not being a volume for the MySQL thing. Although that doesn't sound right. And honestly, I forget where the so let me look real quick. Let me look at the documentation, see if I can find something without spending too much time on it.
Yeah, I didn't want to sidetrack you. Uh, I seem to recall something about that binary log file, and
I just totally forget where the configs are stored. Like they don't, I know with
mm,
this image, they don't want you actually writing to the config files themselves. They want you to use these commands, these command
yeah.
options. Let's see. Yeah, oh yeah, here we go. This is so like you can use a volume and then map directories and like configuration files. So I think
Mm.
that's what they want you to do. And so, but oh, actually, yeah, there was something else. So you can specify the location that you want for that, and that's something we're going to cover in the next demo. So
Okay.
let
Didn't
me.
mean to sidetrack you there.
No, that's a good question. The one for the GTID method has some more configurations, and I think like one of those is we specify the binary log position. I don't have to do that. I had to be the name conflict because they're on the same, they're the same across the demos. Okay, so let's do here we go. And that was the directory I was looking for. So when we start up this container, we'll be able to see the binary log. Okay, there we go. See if we can actually.
Look at it inside the container.
Yeah, I'm gonna try. I never actually bothered catting the file to see if it shows anything that's legible, but let's see. Var lib MySQL, that's there, and then we should have a MySQL bin
In the bin.
log cannot access. Well, right, it's a cat.
That's
Oh,
MySQL bin dot 00 something.
yeah. I was looking at this up here.
Right,
Maybe we didn't. I guess it doesn't exist yet. Yeah, it's not exactly readable.
Yeah.
But there it is there. This is var lib MySQL.
Mhm.
Yes, this contains the log files. And see, I guess there's like another, is this another MySQL directory? CSM's general log. Okay, yeah, I don't know. I haven't spent too much time studying all of what's in here. This is a directory. I think I told you about one of the meetups where um you can't add anything to this. So like other containers might be like Alpine Linux, where I can do like APK add them or something.
Oh yeah.
And like it doesn't come with a vim, and I can't no like apt get or anything. So no, I think that's oh nano. Yeah, there's no, it's like no editor in here at all. So all you can do is like cat or grep. Anyway,
Yeah, they don't want you monkeying around.
nope. So yeah, for the GTID one, let me bring up my notes here. So yeah, same thing with the bind address and the server ID. There's a few additional configs with this. Most notably is the GTID mode on and the enforced GTID consistency. So these two are really how you opt into it. I think some of these commands, now that I'm looking at them, are superfluous. I don't know if I need log replica updates on, but this is what I found that got it working for me in these containers. So probably won't walk through the whole thing, but I will get it set up to replicate with tables. So I'm going to close these out so I can refresh the connections. They're on the same port, but they're different servers. Okay, so I'm loading up my notes. So you still need the replica user on primary, but you don't need to get the binary log position. I think what you do is this, you do have a source auto position. I think you can, all the examples I found have it using one, which I probably the beginning of the file, but I'm guessing you can give it a higher number if you want to try not to pick up everything. But this is all the same. And then you start the replica. We'll do create database, use database, create a table, and insert some data. And then on the replica side, use the database and select data. And there we go. So by and large, very similar setups. but you will see these different approaches in various documentation. So thought I'd show both. I'm gonna see. I'm gonna just tear it down real quick before moving on. Cool. So that was everything for MySQL. Any questions on MySQL? Or okay, cool. And then shut these down. Then we'll talk about Postgres.
Have you tried with the my SQL? Have you tried after the replica is working, if you fail the primary, um, does things still work, or
We can try that real quick. Yeah, we can just hopefully it doesn't complain about connection. But let's see if I set it up. Oh,
I'm trying to remember back when I did it, because I think there's two different approaches, at least that I did. One was the replicas were only read only unless they got promoted to be the master or primary, then they were read write. So if you lost the primary, you can continue reading, of course, and then you also could write. And then when the primary came back online, you would switch back over to the primary, and it would sync up.
yeah, I'm guessing the answer is yes, because as I showed in the last example, you could still write to replica. I think it's just a matter of but let's try it.
Hmm. That's right. You did like you changed the
I changed the user on the
the
replica.
user. Yeah.
So like if I had one data or oh, no database selected.
Hmm.
Cool. So now what we do here is simulate a crash by taking down the primary database
Hmm.
or just primary. Oh, my Tmux does that sometimes. It puts me in the wrong directory.
Hmm.
There we go. So
Yeah.
just shut down the primary.
Hmm.
We are getting errors from replica saying that, oh, wait, this is saying start storing their passwords. Oh, it's still complaining about the not secure. I guess it will constantly complain if the password's not secure.
Yeah.
Uh, but we should still have full access to this, right?
Hmm.
I can still make queries and I should be able to just use it as a fallback, right? So like now I can just update data, right?
Yeah.
Um, it's just going to be uh, you'll run into problems later if you try to bring the primary back online and you have new data on the replica. You'll probably start getting some errors there, especially if you have things with like the same IP or on a table like this that has auto incrementing IDs and you've written to here, but now you try writing in the primary and now the IDs are inconsistent. So yeah.
Yeah,
Yeah, I mean,
that was always a tricky part, is when you fail over and going back. I hated for that scenario to ever have happen in production.
yeah, I didn't spend too much time like figuring out how to debug the failovers, but I imagine the first thing that comes to mind is if your main crashes and you uh, fall back to your replica, and this becomes the new main. Um, if you want to bring back another, you want to have two again, right? I think this becomes this. The replica now stays as the main, and then
Yeah,
you spin up a new replica.
yeah. I think that's the way I ended up doing it too, because it was too much trouble to try to salvage the original
Mm.
primary. So the replica became the new primary, and then when we brought the other one up, it was now the standby or the secondary. Yeah.
My follow-up question to that, I certainly don't have the the data to try it here, but if you have real production database with millions of records and you spin up a new replica, how long does it take to get up to date? Like, is it reading the log line by line and taking you know minutes or hours to get up to date, or uh, is it pretty instantaneous? I think I did try something like that with the Postgres, like, but just like briefly, like if you had a primary and you start writing data to it, and then you bring the replica online, it did copy the old data over. But uh, yeah, I'm curious how long that would take in a real world scenario.
Yeah, that'd be crazy. With millions of records, I wouldn't want to. I wouldn't want that to be my job.
Right. Okay, cool. Make sure I can. All right, cool. Let me go back to the slides, talk about Postgres. So Postgres is similar. They're a little more, uh, I guess, strict, for lack of a better term, on how you do replication. Um, so physical replication, instead of a binary log, we have a write ahead log or a wall. And you can have, I think there's like multiples of these files, like not just one file, it's like multiple files. Um, so whenever you write to the primary, that data gets written to a write ahead log. And then um, if you have physical replication set up, those exact write ahead logs are streamed over to the replica. Um, and it's more than just the write ahead logs. It's all the data files from primary are copied over to the replica. So the replica is a true mirror of the primary. Um, so as a result, you can confidently use it as a standby. If your primary goes down, you can switch over to it. I think there's probably some configuration. I don't mean to probably elaborate a little better. The configuration files end up being the same between the two, but um, the replicas are considered read only. So you can't actually write any data to them. But if you want to make it the primary, you'll have to disconnect the replica connection. But similar to the MySQL physical replication, everything's copied over. So schema changes, data changes, that all gets copied. And because all the configurations and data are the same, you probably need to be running the same version of Postgres between the two, since they're going to be as close as possible. And we also have logical replication. This is a significantly different approach. Um, so this is a hub sub model. So instead of replicating uh, your entire server, you can set up replication that is specifically focused on databases and tables. So if you have a you can have a replica database that has this one can accept writes, so you can have other tables in conjunction with this, but then you can subscribe to a primary database and pull in changes for specific tables. So this is very selective. And you can even be selective down to the table column. So if the primary database has, three columns, your replica database can have additional columns on top of that. So the only thing that needs to match are the columns from the primary. But the trade-off with this setup is because you're really just subscribing to changes from tables, schema changes aren't copied over. So if you update a table and you add a new column or remove some columns, you need to apply those schema changes independently, which it can get tricky during uptime if you're constantly receiving new data, right? So let's go into a demo of this. We'll do the physical replication demo first. Have some setup notes here. I just to show the Docker setup. The Docker images do let you specify volumes. So that's what I've done here. So I've created a volume for each and mapped it to the data folder for Postgres. So I think I'll start with both of them. So maybe this setup's a little more complex than the MySQL example. I'm going to move through a few things quickly, but first I'm going to show real quick is I'll show us in the replica or the primary. I think we'll do the replica. So I'm going to open up a batch shell onto the replica, and just want to quickly show this PG HBA conf, which has connection rules in it. So I think it's var lib Postgres data PG HBA conf. Okay, so I said I'm using a volume here, so I've already made some of these changes and they're already persisted. But when you're doing replication, either with physical or logical, you'll need to set up a rule similar to this, where and probably make it a little more secure, but you need to have a replication rule that is for MD5, which is password. So you need to have a password allowed replication, essentially. But you'll probably want to make it a little tighter on address. Like I'm opening up all addresses. You'll probably want to scope this to whatever your primary server address is. I also opened up the bash for a reason, and that is on the replica to set up replication. You have to delete the initial data files that it gives you, and then you have to use this PG base backup command, which takes the host of your primary and basically your credentials for that, and then the data file directory that you want to copy over. And then I forget what these options are, but basically you're going to sync the data folder of the primary to the replica. And so that ends up being a streamed connection. Whenever there's changes on the primary in that data folder, it's going to get streamed over to the replica. So I had to run this pretty quick because Docker will crash like within a few seconds once it sees that I'm making changes to the data folder. I'm forgetting something now. Yeah, I have to actually have this replica role set up first. So going a little bit out of order, I'm going to open up PG admin. We have to have a replica role created on primary first. Starting up here. No, I want that over here. Cool. I connect. All right. So I'm going to copy the command for creating a replica user and run that. Oh, it already exists. Might not have cleared this out from the last time. All right. So I'm going to delete the data folder from the replica, and then I'm going to set up the streaming backup. Okay. There we go. Cool. So in the process, it actually started complaining and it's restarting, but I'm going to restart both of them because I've had issues with this getting synced up correctly the first time. But that should be mostly good. Let me refresh this connection. All right. So now we'll kind of do the same thing that we did on the MySQL side. We're going to create a database, which we'll just do through the UI here. Call it pizza deliveries. Save that. I'm going to open up a query tool and similarly load in a scratch pad. So this is for physical replication. So we've already created our replica role. We have our database. So from here, we can start creating tables, insert some data, ensure that that data exists. And there we go. On the replica side, open up connection to this. And you see we already have our pizza deliveries database. So I open up a query on this. I can do, select all from users. And we should see our data showing up here now. So everything that is applied to the primary is immediately copied over to the replica. The difference from MySQL, as I mentioned, is the replica is read-only. So if I try to do delete from users, we're going to get an error, and I'll show you how far this goes. So cannot execute delete in a read-only transaction. Similarly, if we try to run an update, this will fail. And this will fail as far up as trying to delete the database. If I try doing this, it's going to get an error. It's going to error saying cannot execute drop database in a read-only transaction. So the replicas are pretty locked down so long as that streaming replication setup is in place. Any questions on Postgres so far? All right. I'm going to tear this down, and we'll do it again for logical replication. I think actually this is as simple as will that work? That's because I had the window open. There we go. Okay. Cool. I'm going to set up the demo for logical replication. So a few things I've noted here. As before, you want to have a replication connections allowed in your HBA conf. For logical replication, you're going to have a few additional settings. So you have a wall level of logical, which is saying that you're going to allow subscriptions to read the wall file instead of the wall files being transmitted wholly over to another server. And then we have wall senders and replication slots. So wall senders are, I think these are the processes that transmit wall files to subscribers. Replication slots are actually an exact match to your subscriber. So you have a publication that says, publish all events from the users table, and then you have 5 subscribers reading that specific publication, then you're going to have the subscriptions are on the replica side, but whenever you set that up, it uses one of the replication slots. And I actually misspelled that. It's replication slots. So each subscription uses a replication slot. So and that is an active connection. So the setting is in place to, I guess, probably keep system resources in check. If you have too many publications and subscriptions set up, I imagine that the connections get out of hand and you start having server crashes and things. So looks like our containers are up. I'm going to go back into PG admin and refresh these connections, since these are new databases. So as I mentioned in the slides, the schemas on these are totally independent. So I'm going to have to create the database manually, the database and the tables manually between these. So that's on the primary, on the replica. All right. Open the scratch file. Let's see, this is for logical replication. And then here, replica, logical replication. Cool. So I'm actually going to create the tables first. And this is on the primary, I'm going to add this replica identity full, which allows it to copy updates and deletes over to the replica. Otherwise, I think there's a security thing that only lets you do inserts. So that's on the primary, and then on the replica, we'll create the table as well. So, yeah, we have users tables set up on both, and I'll actually demo the part of being able to insert data on the primary, and then later when we set up the replication, have that copy over. So just to show, we have users tables on both. Right now, they don't have any data in them, and so we'll insert a couple, three records. There we go. And because we don't have any kind of replication set up yet, if I try to select from the replica, it's completely empty. So now let's look at the publications and subscribers. So up top, I have the line create publication, named my publication for all tables. And this is just a simple way of saying that I want to publish all events, I want to publish events for all tables to my subscribers. But I can be selective with this. I could say, instead of for all tables, I could say for table users, right? And that would only publish changes for the users table, but we'll keep it as all tables. So we'll set that up. And then on the replica side, we're going to create a subscription. So we're going to name it replica subscription. The connection has our credentials, so our database name, host, user, password, and then the publication that we want to subscribe to. So we'll run that. All right. Now you can see the message that it created a replication slot on the publisher. That would be the primary. So just check the servers real quick, see if it's looks healthy. Yep. I see logical replication table synchronization for table users is finished. So that indicates that we probably have data here now. So if I select from users, all three of our user records have copied over. So our replication's in place. We'll even do one more insert to get a fourth record here. And we'll see that that should copy over. There we go. So let's see. What did I want to show? Yeah, so we have replication in place, but the replica is, yeah, this allows write activity as well. So I can update actually, let's copy this over to the replica. Actually do that there. So let's say, no, not really creative with names tonight. So that if we updated our user record there, our record with ID of 1 was changed. But similar to the last example, you could have tables. You can have other tables on here that are not affected, right? So unlike the MySQL example where you can create tables, but they could still get destroyed if you destroy the database. This replication is specific to the tables that you're subscribed to. And also the columns, right? So right now we have two tables that are they're named users, but they have the same fields. But we can add other columns to this that are not affected. So I think we can do something like alter table users, I want to add a create at timestamp, and I want it to default to the current time. I was looking at this last night, but I forget how to do it. So I'm going to cheat and look at this. Scripts created at current time. Current timestamp is what I'm looking for. All right, so we'll do created at add created at a timestamp, and it's going to default to current timestamp. Let's see if this works. So I think that's going to have put the current time in all of them, but yeah, so I put the current time in all of them. Now, what's interesting, now that we have this column over here, if I start inserting data into the primary, we don't have that timestamp over here, right? So if I select from users, we don't show that, right? But we just added records 5 and 6. On the replica side, that data should have copied over. Now, if we select from users, we'll see the exact time that they were copied over. We're essentially reading the inserts that occurred on the primary, inserting them into the replica. And because the field defaults to current timestamp, it automatically fills this in for us. But this setup is still dangerous, right? Because we can, I'm not going to run it because it'll crash. It'll kind of crash our application, but I could delete records, right? I could delete the entire table, and then that data would be lost from here. So that you get some advantages to this, and that you can have different tables and columns, but if you have the ability to write to various things on replicas, so there's a bit of danger with that. And then similarly with schema changes, right? As you saw, we just added a column to users on the replica, but if we wanted to add a column to users, or better yet, look, if we created a new table entirely, right? Let's do that. That would be more fun. If we created, we'll call this pizza since it's a pizza delivery database. So we'll say name and size. If I do that, we've created the table, but even though the publication is for all tables, it's only for the tables that it knows about at that time. So even if the way to reset it would be to drop the subscription and then recreate it. But even if I did that, the publication is for the tables that it knows about at the time. So it's not going to track the table. So before I show how to do that, I'm going to insert one record in there. Pizzas, name, size, do say cheese and extra large. Cool. So we just created a table. We just inserted data into it, but we want to get that data in now. The first thing I have to do is drop the subscription. Now, you could go the route of creating another publication, but then you run the risk of duplicating data. So I don't think that's safe, but that is an option. Like you could just create a new publication and a new subscription on top of that, but then you risk duplicating writing the data more than once for the same record. So what I'm going to do is drop the subscription and then drop the publication and then recreate the publication and recreate the subscription. Actually, I'm missing a step. I got to create the table. I need to create the pizzas table before I do that. There we go. So now when I create the subscription, cool. Might take a minute to copy over, but should be able to select from pizzas now. And yep, the data is copied over now. So something to keep in mind if you're using this method in it, or yeah, you're using this replication strategy and you need to make schema changes. It's a little more complex. You probably have to manipulate the publications and subscriptions, try to get as little of a data gap as possible in that downtime, or maybe you have downtime when you turn the servers off while you're doing this. It's a little more tricky with this, but that's effectively how this is done. Any questions on Postgres? Cool.
Seems like you got more options with Postgres than MySQL.
You have more options, but it can be wildly more complex. So these subscriptions, you have replication slots on here, which I think you can just, I forget if it's on this table, if it's on this database or not. I think you do like something like select all from replication slots or PG replication slots. Because there's like a PG drop replication slot thing here, but maybe it's PG replication slots. Yeah, there we go. So these are all the slots that are used. I'm not sure what this one is actually. Logical, temporary, false. This might be the old one that we removed. So this table represents all the slots that were used, and you can see like which ones are active, right? And because we actually set this up to have a maximum of 10 replication slots, there can only be 10 active subscriptions at a time. So I showed the simple example of one publication for everything and one subscription to listen to everything. But I could, in theory, create multiple subscriptions on this publication, and I could have publications for each table, and then on a larger system that's probably eating up memory, right? So you have more memory concerns to think about with Postgres. Right. That's it for this. As a little bonus, so Michael will know what I'm talking about a little bit, but there was a podcast someone did with DHH, the creator of Ruby on Rails, recently, where they were talking about using SQLite in a production environment. And SQLite, it's like a serverless database. So like everything is self-contained in a file. So like if I'll open up a new shell the shell real quick, and then just do like, yeah, I've already demoed this one. Yeah, I've already been messing with this. Oh wait, no, I didn't see the into it. All right, cool. So I can do like SQLite 3, yeah, fruit, we'll call it fruits, like the example here. So now I can do, I always forget the syntax for things. Let me see if I can copy like a create table from somewhere. We'll do the ID. I don't think this is not valid in SQLite, but I can do like create table users and then insert into users, right? And I can run that a bunch of times. select all from users. And this is all just writing into this database file. So I can exit it. That's not the command, is it? Forget what the command is for that, but I can call SQLite 3, the name of the database, and I can give it a string like so, and it will just print it out. So it looks like it's printing out something similar to CSV, except it's bars for separation. But everything is contained within this database. There's no additional server files or things to keep track of. So, but because I was working on this talk, I'm like, well, does anybody do any kind of replication with this? Like, is that a problem that people run into? And I'm not. I did find some things, and I'm not sure if it's just like a sales product trying to create a problem, but because and the thing that comes to mind is you want to quote unquote replicate the database. You can listen for changes on this fruits DB file, right? And like say the file size changed, like right now it's like 8192 bytes. If there's any changes to the file, then have something that watches it and copies it wherever you want. But I found out that there you can configure write-ahead logs in SQLite and like listen for specific changes. And there's services out there that will watch the write-ahead log and copy those changes to cloud storage providers. So I won't do the demo here, but I'll show the guide that I found, and it's called Lightstream. And their service is being able to stream SQLite databases to cloud providers, so S3, Azure, Google Cloud. So you do go into their getting started. They have a thing where you set up this Docker image with MinIO, which is it's mimicking a cloud storage service.
Mm-hmm.
So you can go in here and create a bucket, and then set up your database, create a table, insert some records, and then set up your light stream to replicate that. And this will be a long running process, and usually they run it in a background service like it says here, but this will constantly watch for changes in the database and then stream those up to your cloud storage, and then you can restore it at any time to a local file. So I thought that was interesting. As I understand it right now, SQLite is usually, if it is used in a production context, it's usually for local applications. So if you have, something running on your phone that the data is self-contained, it doesn't need to communicate to a server upstream, then all the data can be stored local to the device on SQLite. But maybe there's some development out there that's making it a little more production friendly if other resources need to read it. So I thought that was an interesting development. That's all I've got. I put some resources for guides that I read for setting up the different replication strategies for Postgres and MySQL. This article in particular was interesting. So the logical replication that we were just going over, it's a fairly recent development. This is an article from 2011 from someone that is trying to advocate for logical replication and basically saying that you can't replicate like part of a database. You can't replicate data at all on the standby. You can't do, all these different things that you can't do because um, basically it's an all or nothing approach as with physical replication. So this seems to be at least one of the sources that generated conversation for setting up the logical replication thing that we were just demoing.
Hmm.
But yeah, I'll share this. I'll share the slides and I'll share the recording on the meetup once this is done. Any questions on anything?
No, that was neat. Reminded me of when I was playing with the MySQL and replication a couple years back. We ended up not going that route, but I could definitely see the good use cases for it. One thing, I I don't know if I just missed it when you were talking, but I think you mentioned about with the replication, you might have a user that writes to a replica. Um, you can control that through user permissions. So if you did want to give a department or a client their own replica read only, you can do that, and through user permissions, don't allow them to mutate the data.
Right.
They can just
Yeah.
read the data.
I think I briefly mentioned that up here. Like if a customer wants direct access, so
Yeah,
you can do a combination of both. You can put the data on a replica, and then you can give them a read-only account. Probably make it doubly secure.
yeah. We had an internal customer that they wanted to write their own queries. So we gave them read-only access to our database, but we learned that they weren't writing the most performant queries.
Yeah.
So we basically created a replica, but we just do it like a daily. So we do a daily dump, or we did a daily dump, and then they loaded up on their side. So it wasn't a real-time replica, but it was good enough for what they were doing. And that way, when they wrote their queries and crashed the database, they were crashing their database, not ours.
Yeah, that's smart. That's and then that's like probably the most performant scenario, right? Because it sounds like you're taking snapshots of the data and you're loading those up nightly or daily. So it's like not constantly being streamed over. And then, like you said, if they're writing non-performant queries, it's only impacting their data, not or their database, not the main application database.
Yeah.
All right, cool. That's all I have. I'm
Neat.
gonna stop the recording.